We're going to practice going back to vertex form one more time. This is in standard form. To put it in vertex form, we need to find the vertex. You should notice that's been our first step in everything, yesterday and today. To find the vertex, you do x equals negative b over 2a. Well, b is a 4, so we're going to do negative 4 over 2 times. Now this time, don't forget a is a negative 1. So we get negative 4 over negative 2, which equals a positive 2. To get y, you have to plug it in. So we'll do negative times the 2 squared plus 4 times the 2 minus the 5. And that's going to give us a negative 4 plus 8 minus 5, which makes a minus 1. You finally found your vertex at 2, negative 1. Remember from the last problem, this is h, this is k. Step 2. Step 2 we like, it's really easy. Find a. A in this case is negative 1. So I'm going to write step 3, my general form in vertex. This is yesterday's lesson. We'll plug in a, which is just a negative or a negative 1, x minus h, so x minus 2, square it, minus 1 on the outside. That's how you put this in standard form, or in vertex form from standard. We're going to go to the back and we're going to apply. We are going to make what we call a conjecture. We're going to be given some information and we're going to make a conjecture about something. The last problem in the notes is problem 4, and it's interpreting a quadratic graph. The new River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You see the single arch right here. They're saying this is the biggest bridge in the world. You can model this arch with the function, and here they give you the equation. Remember, an equation is a model, where x and y are in feet. How high above the river is the arch? How long is the section of the bridge above it? Alright, we're going to start by figuring out how tall it is. We write y, we have to find, now anytime they're going to ask you for the minimum or the maximum, step 1, because we're finding how the min or the max, we're trying to find the max, we're going to try to see how tall this thing is. That means step 1, guess what? Find your vertex. We write x equals negative b over 2a. That's going to be a negative b, in this case it's negative 0.847, over 2 times a. In this case it's negative 0.000498. Work that out, get an approximate value. Should be 850. Make sure you put this in your calculator right, or else you're going to have a way off. We're going to plug this in. Now this is how far x is for it, okay? So if this is the arch, and this is the max right here. This is the max. You have found this distance. This distance is 850. We need to plug it in and figure out how tall it actually is. Y equals, plug it into the equation, negative 0.000498 times what we got, 850 squared, plus 0.847 times what we got, 850. Work that out. You will see that it is approximately 360 feet tall. Now what you have to realize is that's just this distance here. Okay, this distance that I am currently drawing is 360. But remember that this is already above the water. So we have to add on another 516 like the picture says. So we'll do 360 plus 516 and get, and this is an approximate, 876 feet above the river. There is a second question here, and the second question says, how long is this section of the bridge above the arch? So here's our arch. Here's the x value. This was the max here. We figured that from here to here was 850. So from another here to here, that's just another 850. 850 and 850 makes 1,700 feet long above the arch. And we just added those two together. Flip to the back. We're going to do that one more time. There's a bridge in China. It's the oldest bridge that's known as an arch bridge. It dates back to AD 605. You can model the support arch with this function, where x and y are measured in feet. How high is it above its supports? When it asks how high, it's asking about a maximum. That means we just find the vertex. We'll do negative b over 2a, so we can find x. That's going to be negative 0.131148 over 2 times negative 0.001075. Plug those in. You're going to get approximately 61 feet. That's how long it takes. Here's your arch. They're saying it takes 61 feet to reach the max. Now we're going to figure out what the max is. It's right above the water. So plug in 61. Y equals negative 0.001075 times 61 squared plus 0.131148 times 61. Plug that in. You will figure it's only about 4 feet high. That's it. It's probably because they didn't have a lot of machinery back there to make them real high. But that's about 4 feet above the water. And if you look, it's going to be about 120 feet long total. Part B says, why does the model in Part A not have a constant term? The reason it doesn't have a constant term is because it doesn't need one. The y-intercept is where it starts. Okay, that's it.